We're still in Russell Smith's book. We're doing some electrical control, and we want to talk about combustion control. And we said the reason we have control is because we don't want to do things manual. So we'll try as much as we can to put more control so things will be automated. Same thing with your car. If you had a car in the 70s or 60s, probably they had very, very minimum control. Now your car has way too much control. Pressure sensor, transmission sensor, this and that, too many sensors. So the car can run efficiently without your help. The newer cars have even more and more control. So I don't know if this is good or bad, but for our intended purposes here, nobody in the house would like to go and deal with the boiler. They just want to hit the thermostat and get some heat. They want to leave the rest of the control to the machine. Again, what are we controlling? We're controlling the inputs. Your input is a thermostat. You want the temperature at 75. The system should deal with it. It's like when you go in your car and put your cruise control at 70 or 65. You don't want to deal with anything. So some cars will accelerate, some of them will even brake. They will shift for you, and you just sit there and maintain the speed. What is the car doing? It's monitoring the speed, it's monitoring the gas, and it's monitoring the brakes. And again, there's a lot of control coming in and out. Delay. Strike one.
Where are we at in the book specifically?
In the book, that's chapter 13. Basic electronic control, fundamentals, that's chapter 13. And heating oil fundamentals, that's the normal book, chapter 1. If you have the Weinberger book, that's chapter 13. If you don't have it, that's fine. I hope everybody got the normal book now. Everybody has it? You? It's on PDF on Blackboard, and you can also purchase the book. So we will transition next week into the normal book. I will start talking about combustion control. What does combustion mean? Burning stuff. So when we burn stuff, we want to have more control because again, there's fire, there's water, there's a lot of potential for danger. So we want to have more accurate and more sensitive controls. The lid. Class 2011.
Straight through.
They interrupted my show, man. Okay, types of control. We want to control temperature. How do we control temperature? How do you monitor temperature? Sensor, thermostat. You need a sensor. Back in the days, we used to use bimetal to control temperature. Bimetal will expand and contract and give you an indication of the temperature. How else? We had fluid. Fluid also expand and contract. So in the past, this was our mean to control or monitor temperature. Now, what do we use? Two wires that are the similar metals that do what? What are they called? We talked about that a lot last semester. Two wires connected together that produce voltage when they heat it. Thermocouples. So now we use thermocouples. Thermocouples are two wires. One of them is copper. The other one could be other material. They are calibrated to produce a tiny amount of voltage based on the temperature. So you can calibrate those. So for temperature, we can use either bimetal, it's fashion construction of material, and also we can use thermocouples. So let's write that down. Bimetal. What are thermocouples? Two wires connected at the tip, and they produce small voltage. Usually millivolt. Milli is a part of 1,000. Those are thermocouples. How do we control air and water flow? think. How do you control your faucet water flow?
Valve.
Valve. You control the orifice size. So the valve will control how much flow it goes in by changing the surface area. So we have a valve, tube, relate. Strike one, late.
11:15 it said.
No, it's 11. See, excuse one. So 11. It's in the syllabus. So we have a valve. Valve goes up and down. That controls the flow. Make it less or more. But how do we know how much is going in there?
A gauge.
Gauge. You can also have a gauge. How does the gauge work? That's a whole science. Let's think about ways that we can monitor the flow of gas or water. What would you do?
Pressure. I'll use a spring.
Use a spring, what else?
Pressure for the gauge.
Pressure. So there are ways, either one of them is the pressure. So you'll have a pipe in the middle. You'll have a valve, and you have a sensor here, and a sensor here, P2 and P1, and you control the pressure difference, and you know how much flow is there. Question?
Sorry, John, question, but what is the sensor you can look at?
Huh?
What is the sensor you can look
Sensor, they look in, every sensor is different. Sensor pick up the information. So the pressure sensor, that's going to be your tape. A pressure sensor basically has a small plate, and the plate is pushed. Based on the amount it gets pushed, it will send a signal. So we'll talk about sensors again. A lot of elaborate methods. So this is one way to measure the water flow and also measure the pressure flow. But this is only for air. What if we want to measure the flow of water? You're gonna have a different kind of flow meter.
Does that actually spin with the
Yeah.
water going through it?
So this will spin. This compartment size is calculated as it spins. The number of spin, every spin has amount of fluid in it. So you calculate the spins, and each spin will tell you what is the flow based on the compartment size. So this is a way to control the flow of water or gas. With gas, it's a little bit tricky. What is the difference between gas and water? Gas and liquid, yeah.
at? You have a different density.
Yes, which means what? The air is compressible. Water is not compressible. You have water, water is going to be water, same volume. Air, if you push too much in it, on it, it will compress. So compressibility is the difference between gas and liquid. So different flow meters for different applications. 11 o'clock. So these are some of the means that we control flow. You can buy a lot of flow meters for different applications, and probably the gas. If you look at your gas meter at home, you see it spinning. There's a small little wheel inside that control the flow of gas, and also there's a pressure sensor that will give you the density of that gas. So basically the pressure sensor coming in, if the gas is cold, it's going to be denser. So it has to be accurate, and it has to auto-calculate what is the density of gas, so they will know how much gas they're giving you. Otherwise, this is faulty. You can be overcharged or undercharged. That's why once a year somebody has to come from the gas company and recalibrate your gas meter to make sure it's calculated correctly. If not, you will verify. If not, it will be miscalibrated. You might be overpaying or underpaying. And they know how much they supplied you.
And then
So
the sheriff shows up too.
yeah. So timing. How do we control timing? We can do CAD cell. That's electronic. What else? So we can go old-fashioned. You can go old fashioned and use bimetal again. The time for the bimetal to contract and expand has been calculated. And again, over time, this will change. So we'll have, for example, controlling timing. You have a bimetal spring made out of solid or rigid metal, and if it expands, you know, once the heat is disengaged, it will take 1.5 minutes for that metal to go back. Of course, they do a lot of experimentation on it, and you know, after a while, it will go back. Last time 11.
Oh, it is?
Yeah.
That's 15.
11. So we can time that. What about remember the hourglass? When you flip it and the sand comes out, it has been timed, and the teller, this is going to go, this is going to empty in 1 minute, for example. So this is one way of timing. Also, we have timing using semiconductors. So when you do that, the CAD cell control or the primary control has semiconductors in it that they have timers. Timers, you can buy timers, electronic timers from Radio Shack, 15-second timer, 20-second timers. How does it work? There's an element inside that gets heated. Once you energize it, it will take a delay. You can have a delay timer. It will take 15 seconds for it to run the current through it. So that's a type of timer. Pressure. How do we have a pressure sensor? Think of pressure. Pressure is force pushing against the surface.
Sure. Pressure, turn the sensor on.
So there's a pressure sensor. If we look at a simple pressure sensor, I think we have some here.
Pressure gauge.
This is a pressure sensor and pressure control. However, it requires a lot of pressure to operate. And you can sit, if you look here, there's a spring. So this spring will act against the pressure. This thing will open. Once, if you look in here, there's also a small little pin that pushes against the lever here, and that will cause the switch to trip. This is the old-fashioned sensor. It's still in practice. It's very practical. However, the spring has to be calibrated every few years to make sure the spring is not soft. You know about springs after a while, after like a few years of usage, a lot of cycling, it will get softer. So it will lose its property. However, so it has to be calibrated. And if you see the screw here, that's how you set the pressure. This is acting against the pin, and the pressure of the steam is coming from this orifice, so it pushes against it. And it will, in turn, open up the switch over here. So I'll pass this around.
That's for gas.
This is for gas, and this is also for steam.
So is that also called a tricock?
Huh?
Is that also the tricock?
It's different thing, but it's similar.
Similar.
Power plant?
Oh.
Yeah, it's a different thing. There's another way to measure pressure, and hopefully somebody will do. Who's going to do a bathroom scale? So electronic bathroom scale has small, little, tiny pressure sensors. So you step in the scale, there are 4 pressure sensors. Strain gauge. This is a small strain gauge. If you take apart a bathroom scale, there's a small little wire, very inexpensive. When it bends, it changes the resistance. Based on that change of resistance, we can calculate the current and we can transfer that into pressure. So it's very small, but it's very sensitive. You bend it, it will change your resistance, and that can be an indication of pressure. We can put those pressure sensors on vessels, on tanks, and it will detect the tiniest change in pressure. You can put it in a soda can, and you can see the change as you open the can, the fluctuation. This is how sensitive it is. However, it's used mostly for very, very small changes. So it's not going to be very effective to be used in steam. That's a lot of pressure. So this is another strain gauge that can be used for measuring pressure. And you can also get creative to measure pressure. We can put the water column somewhere, and based on the other pressure, you can see it goes up and down because water has weight, and you have to counter the weight. Make sense? We'll see a lot of pressure sensors. Flame level. That is again very, very important in our combustion control because you want to know that you have the right amount of flame. So we all did the lab last week for the Honeywell primary control. And how did we measure the flame? Cat cell. What is the cat cell is showing you? Yeah. How does it? What is the reaction? What do you see in the screen?
Well, I had this thing.
Does it turn off? Turns on.
Infrared?
Yeah.
Oh.
No.
No.
What is it changing?
Resistance.
Huh? Resistance. So flame level. So flame, you can detect light, right? What else the flame has? Heat. What else? Hot air, but that's again heat. So light, heat, what else? Come on. Huh? Point the next quiz for who gets it. Huh? No. No. You shouldn't have smoke.
Color.
Color is also, but that goes with light. Huh?
The gas levels.
Keep going. You're getting there.
Yeah, something to do with timing.
No. It has gas. What does gas have? You're getting closer.
Oxygen.
What does plasma TV have? What is plasma?
In your blood.
And also in TV. What does it mean?
Radiation.
It's the same thing. You're getting there?
Rays.
You what's that thing called?
The rays.
Huh?
The rays.
Okay, what else? You're getting closer.
I'm
We said
sorry.
plasma. We said plasma. We said
Violet.
radiation. What is radiation? Huh?
Thermal energy.
Ion.
Huh?
Ions.
Yeah?
Ionized.
Ionization, has ions.
Something like that.
Nobody would know yes.
That's
It's
ions.
crazy. You know, I remember it's from the slideshow you showed, like, I think it was the last time.
Yeah. So ions, it has ions. And we're gonna use that to change AC to DC. And why do we do that? Depending on how much fire you have. You know how much heat you're going to pump into an industrial boiler? It's a lot of heat. If you put a cat cell there, what happened to it? To melt.
Hmm.
And you can also use infrared, depending on where you want to put it. If you want to know actually how much flame do you have in there, you have to use ions. And you can put a flame rod inside the flame, and based on the amount of ions produced, you can know how much fire is there. Did you notice when you did the cat cell primary control that when you put too much light, it shows the resistance, right? It keeps fluctuating, right? If you put the flashlight on it, it goes really, really low, up to like 7 or 3 ohms. If you cover it with your finger, it's around 3,000 ohms. So that will also tell you how much flame is in there. And that's why they tell you what is the ohms of the reading from the cat cell. Yeah. This is the older one. Next time, try the new one. So when you do the lab, every time try a new control. We have 3 generations now, actually 4 generations. The timing, probably you're gonna only have the 4th and 3rd as the code because the timing has changed. The timing now to prove the flame is 15 seconds. If you cannot prove 15 seconds, you will need to shut off the light, shut off the fire. That's for residential. What do you think the safety timing for industrial?
Even lower.
3 seconds, unless between 1 and 3 seconds. No flame, you shut off. Why?
Bigger.
It's bigger flame. You're gonna flood the chamber with the oil. And also remember this. Listen, if you go to somebody's house, listen. If you go to somebody's house and they tell you there is no fire, and they tell you they hit the reset button too many times, what is the first thing you do before you do anything? And what else?
Down to 4 gallons of oil on the bottom.
Aha! Yes! Go and check, take out the boiler. I know it's annoying. And look in the chamber. If the chamber has been flooded, the guy kept resetting. He flooded the chamber, or the nozzle is broken, and there's a lot of puddle of oil in the burner. What happens if you light it up?
Oh yeah, that's going to explode.
Smoke.
It's not going to explode, but it's going to be a lot of fire and smoke, and it's going to be on for hours to fire all that gas. And it's not going to be in the shop, it's going to be in somebody's basement. The whole house is going to be full of smoke, and it's on you. So, and probably nobody will tell you, I hit the reset button every few hours. Yeah, so be careful, do your due diligence, go on, check with a flashlight that the chamber is empty, there is nothing in there, it's not saturated with oil. When you look at the chamber, what is the material in the chamber? It's some kind of fiberglass. Fiberglass. Fiberglass is porous, right? It's supposed to insulate the heat so the heat will go on the top, because you don't want heat coming out from the sides. This fiberglass can be saturated with oil from too many resets, or if the nozzle is broken, or if you have too much pressure. So light, yeah.
How do you fix that problem? What if it's flooded?
If it's flooded,
Yeah.
good question.
Oh.
Get some rags, get some sand, and clean it up.
Hmm?
It's very simple. It's what is it called? Speedy dry.
What about the installation?
Or catnip, so I used to
Oh,
see
yeah,
that earlier,
catnip,
that,
right?
as equipment.
You should have that
Provide you-
one. Yeah, you should have
You
that
could
one.
put that in like into the chamber.
Say that again.
Like you're saying that you're gonna. I was gonna say, but that sounds crazy. Like how would you clean the chamber though?
Well, you open it up, and you still like you put some speedy dry and you keep scooping it up. It's a very tedious
Yeah, that sucks.
job. Yeah.
Quick way of doing it.
Get some rags, make sure it's almost dry, then you start it up. And you might recommend to change the entire insulation. You can change the entire insulation, it's not that expensive. You say this chamber is completely flooded, I'm gonna open the boiler, take out all the insulation, and put new ones there. But it's going to be an issue. So flame sensors, light sensors, these things will measure the light. Motion sensors, how do they work? We have a motion sensor over there.
Will turn on, something will turn on with your.
So usually they measure the infrared, and sometimes they have a laser beam, some kind of like beams, and if you cut through them, they will activate. You see them a lot on spy movies. Motion sensors are becoming much better, and it's you can find them in many components now. Especially when you go to industrial, they have motion sensor for everything. Make sure that things stay in place. If it moves, then it gets activated. So think of a sensor that you will want to research, and that's going to be in your topic paper. So if you have the Weinberger book, it has some oil burner controls. The reason I do not recommend that book, because it's very expensive, and we're going to cover a lot of stuff. But if you have it, there's a lot of information there about oil
There's a
burner.
couple books that they still don't have.
Yeah. Yeah. So for now, I don't think you need any of the book. Books, and you can look up books online, it's much cheaper. And yeah, by the way, they say they will. Do you know that the bookstore will match up Amazon prices?
Oh, okay.
Yeah. So if you find the book cheaper on Amazon, they will match the prices. That's their promise.
I got financial aid though, so I ain't trying to spend cash.
How do we, guys? How do we measure liquid level? Float. Don't you have that in your toilet? You flush, it fills up, and the float comes up. Sag glass. But float usually can close and open a switch. There's electric strip. Electricity work with some products, not others, depending on the ionization of water. Huh? You could. That's not something we will use, but we might see it in power plants. Liquid temperature, thermocouples. thermometers. Steam pressure. How do we measure steam pressure? This gauge. They're still in practice, they will still use them. They can handle a lot of pressure up to like 9 psi. What is the pressure for residential boilers? Between 2 and 5. Between 2 and 5, you want to be on that. Doesn't exceed 2. Maximum 5 depending on the design. Air pressure, same thing. We have a gauge. How do you measure the air pressure in your tire? You have a small gauge. You stick it in. It pops up. And it's the same idea as this one, just smaller, more sensitive.
What is that?
That's a pressure gauge. So the steam comes in here, and this will tell you what is the pressure of the steam based on what you set it at. Air temperature. So do you think we can use the same thermocouple or thermometer for water and for air? You shouldn't. Why? One thing, reaction time. Reaction time will be slower for air than water. You put a thermometer in water, it will move rapidly, you can see it. You put it in air, you have to wait a few minutes. So depending on the application, you might want to have a thermometer that's designated for air or designated for water. Otherwise, it's not going to give you the same reaction time. Air movement. How do we measure air movement? You can have a small turbine, small fan that moves. What do people do to know if there's air movement from this register?
Put a piece of thing in it.
Yeah, tissue,
Yeah.
just so you can visualize it. So sometimes simple things still work. Like I can't feel the air coming from here, so I have to put something, small tissue or flag, to see if it's working or not. Just make sure you take it out until you finish the job, because it's looking like that. Oil burner flame. So if you look at the cat cell, when we saw it, that's what it looks like. This should not be exposed to heat. So where do we put it? It's behind the electrodes. So it should be far enough from the heat, but it can see the light. If it's obstructed, it's not going to measure and see the flame. So it has to see the flame properly, otherwise it does not work. Also, this is made of plastic. It can melt, it can get some soot. If you have a really dirty burner, it's always like smoky. This can be covered with soot. And this also over time it will disintegrate. So it has to be changed periodically. It's not that expensive. And you can change only the cat's eye, get a new one, probably like $1 or so. And the resistance changes with light. Wanna try that? So you know those bathroom lights, night lights, where you put it in your bathroom and if it's dark it will light up? It's the same thing. This one is more accurate and bigger. So if there's no light, it's dark, the resistance is very high, which means it will cut out the circuit. If it's too low, if there is light, the resistance will reduce, and that will enable us to know how much light is in there. So I'm gonna put that in the So you go to somebody's boiler and you want to know what's going on with the light. You have to measure the gas condition. So you put it on ohms. So what is it saying now? 96 ohms. That's very low. Cover it. 4,000 ohms. Open it partially, a little bit.
What's the maximum amount of ohms you want?
You want anything more than 10,000. This was like 30,000. See the kilo ohm? So now it's less than 1,000. So when it sees the light, it should be less than 1,000. If it sees the light and it still have more than 1,000, you have to change it. So if it sees, put it in the light directly.
So far, does that say on the manufacturer, on the bag that it comes in?
Yeah.
It does?
It should.
Okay.
So that's 12 ohm, that's nothing. Cover it up. 2 kilo ohms, which means 2,000. That's enough to stop the control. So this is how you test the cat's eye. So in the dark,
And you just put it in your hand, yes, I mean,
huh?
whatever you were doing, you just put it in.
Yeah, that's the test.
Yeah.
Yeah. So for the cat cell, I'm gonna write it down because it's gonna be in the oil burn exam. More than and less than. So this is the cutoff. Of course, the life and sensitivity of the cat cell will degrade with time. Everything degrades with time. So eventually it will degrade and you have to change it. If you don't get those two numbers, then you should change that.
You said in the dark, anything less than 10,000?
Yeah. More.
Oh, more.
That's more. Should I write it down? Water level, as Tim said, we can use a float. The float usually control a valve. Depending on the temperature of the water, there's a gasket here and a small valve, and the reason it's a little bit large because you want enough pressure to shut off the water flow. And you can have an auto feeder for some steam boilers that use a float. You have this in your toilet, and sometimes the gasket gets dirty, or so it does not stop flowing, it keeps flowing and overfilling the toilet tank. This is more advanced one. Again, it's still a float, goes up and down to measure the level. So there is a low water cutout that is very, very important because in steam, if you run low in water, what will happen? You're gonna boil a lot of steam, it's gonna rapidly change and it's going to increase the pressure and eventually the boiler will explode. So low water is very, very important for steam. Usually now for most boilers you have to go and fill it by hand. Or you can put a $500 auto feeder. So whenever it gets close it will fill and stop. So you can do that, have an auto feeder. So low water cutoff mechanism, some of them just cut off the flow if there's too much, or some of them will activate an alarm that you have low water. You have the same thing in your car. If you look at if your car is newer than 2000, probably if you go to the windshield wiper tank, you see a little float, very small one. So when it goes really low, it will signal you that you have low water in the washer fluid.
That's how you tell when your gas is low.
Yeah, that's also how we would know that your gas is low. There's a float in the water in the tank. It goes up and down. And what else? So for water, for gas, just to tell you how much level you have. Also for oil, if your oil is too low, it will give you an indication. Any questions about water floats? We'll see some of them. Again, those are another mean of control. I hope somebody picked that up as a sensor. So as I'm talking now, pick a sensor that you feel comfortable with and do some research on it. Steam pressure. If steam is used for heating, there must be a steam control cutoff. That is the steam control cutoff. So this one is set at 2 psi. If the steam in the system exceeds 2 psi, the system should shut off. If this is faulty and the steam is too high, then you might have to change the pressure. That's why you have this in conjunction with the steam pressure inside the tank. So you have to compare the cutoff between the steam, the reading on in the gauge, and the cutoff in here. Solenoids with a diaphragm. We talked about solenoids. There are valves, and there's a diaphragm, small little diaphragm that closes or opens a pin based on the pressure gauge. And that's also in here. If you look inside, there's a diaphragm, a small little hole that controls this pin over here. Let me show you. So you see if you look inside, there's a small little hole. This little pin goes up and pushes on this moving lever, so it will push in. It's already been pushed by the spring. So if it exceeds, it will hit. You see this little pin in here? See it? When this is pushed, this switch will be open. So you'll have your main circuit breaker, your main wiring here is a switch. You put it around here. So when it will come, the hot will come from here and goes out from here. And once this is exceeding the pressure, it will trigger the button and will cut off the circuit. And you see the setting here is at 2. So at 2 psi, it should cut off, and you can change the setting. This is actually the differential. This is the setting over here. And this you can change by a screwdriver. This is really fun, and you can again automate a lot of things just by using those little components. And again, the more automation you have, the more efficient the system will run. They also tell you in the highway, it's always better to use the cruise control. The cruise control is way more accurate than your foot. Even though you're driving 60 miles an hour with using your foot, cruise control will give you better fuel mileage than your foot. So machines usually are more accurate because they have more sensitivity. Huh?
Isn't that dangerous?
No. It's designed to do that. It's designed to do that. And now the new car 2017 and 18, they have also engaged cruise control. So you can drive behind somebody and you put the cruise control at 75, and if you get too close to the car in front of you, it will slow down by itself, then pick up again. And I also have cameras that can monitor the lane, so it will disengage if you are going out of lane. So that kind of helps a little bit. So again, pressure switches also operate a safety relief valve. Safety relief valve is put for only the extreme cases, that if all these safety things did not work and somehow the steam is going out of control, you're always going to have a steam safety relief valve. It can be used for air, or it can be used for steam. We can have one here. This is a safety relief valve. It's open from the side. It's always tagged with the expiration dates and the pressure. Usually safety relief valve is set at 60, 30 psi for residential. And every once a year, you should go and open it and make sure it's working, because it can get stuck. If you open it and it leaks, that means it's bad, it has to be changed. They're around like $45 calibrated. And what is this pipe going to?
Blow down.
Blow down. And remember, he said blow down, not blow sideways, not blow in your face. So make sure you have a pipe connected here and all the way to the bottom. If you go to a house and you see this is just like pointing anywhere, put a pipe in it, blowing down. Because there is no point of this blowing in somebody's face or on the wall. Yeah.
There costs some pretty good an asshole and the tech left like versus.
You got to take responsibility. If you're doing this job, you're gonna have your name on it. You're gonna have your name on it. So take responsibility and fix that. I did a few jobs where the steam valve, with the relief valve was leaky, and I went there to test it, and when I tested it, it started leaking. And the customer said, hey, it was okay before. Yeah, but it was supposed to be tested, so it's broken. I tested it and it's broken, so it has to be changed. And eventually, like, oh, it wasn't leaking before. Yeah, I know, because it was broken. So it's not doing its job. It's a safe relief valve. So it's supposed to go there, turn the boiler on, and open it, and close it, and make sure it's functioning properly. And again, if you see, it has a model on it, size, and approval, and also when there's a tag here, it tells you when it was calibrated, and you should put that in your log sheet. Hot water control, aquastat. Again, more controls. So this is also related to Felipe's question about sensor. What's a sensor? So this is a sensor. This is a liquid filled tube. It's a reservoir, and if you see, there's a capillary tube goes around. And what it does is the liquid here, when it's hot, it will expand, and it will push against the diaphragm, and that diaphragm will trigger a button. So when we did the cat cell, we had some of these. So these tubes come in different lengths. You can buy the whole sensor here. If you look inside here, there's a diaphragm, very thin, kind of aluminum foil plate or diaphragm, and this is filled with liquid. Over time, this can get broken and become empty, and the temperature rating for this is around 220, 240. If you go too hot, it might explode, or it might leak. So this will be, you stick this into the water tank, and it should sense the water. And if you notice, it's made out of copper, because we want to be having very fast reaction time. The new aquastats, they have thermocouples. So you put the thermocouple in there, and it's supposed to be sensitive. But you'll see these in the field. They're very reliable controls. It controls the water temperature inside the tank.
That's the max heat load for that is 240.
Yeah, 220.
220.
So it should not be boiling. 220 is the boiling temperature for water. So you can see how long this is. This can be up to 6 or 7 feet long. This is the simple aquastat base. Since this is filled with liquid, you want to make sure that it's not kinked and you're not obstructing the flow of the tube. What happens if by accident it was kinked, to close the shelf on it or something? What are you going to do? Replace it. It's not fixable. Once you bend it, it's gone. So you have to replace the whole thing. And when in doubt, you can test it and see if it's activated or not. You might have to change it. The liquid might have leaked inside, and the liquid is very toxic, by the way. So
What
we're
is
not,
it? What's the liquid?
I think some kind of combination between glycol and alcohol. So it should not freeze. Also, it's very sensitive to expansions. So aquastat is a Honeywell brand name. So now we call every water sensor an aquastat, but aquastat is just a name branded by Honeywell. It also can be called remote bulb thermostat. In the case of liquid expansion inside a tube that is sealed, and this will push against the plate. Again, it's all technology. In the beginning, we started with all mechanical controls. We had a lot of mechanical controls, then we transitioned into electronics. They all have ups and downs, advantages and disadvantages, but the electronic controls are becoming more and more reliable, and they last for a long time. So now, probably if you replace new controls, you will use electronic controls. So middle changes resistance based on temperature. You can have something different called a thermistor, not aquastat. If you took fundamental of air conditioning or refrigeration, probably you know something called a thermistor. A thermistor is placed in your fridge, and you see a thermistor also in the AC. If you look up in the AC, you'll see a small thing on the front radiator. That's a thermistor. It changes resistance based on temperature. Okay. This is a picture of the all thermostats. It has the bi-middle concept, which means Just think about it a little bit. Two metals, they are different. Everything expands with temperature and contract by low temperature. So if we have two metals stuck together, and one of them expanding, one of them is not at the same rate, it will eventually bend. So this was the idea of having an open and closed switch. So when it's too cold, it will contract and open the switch. When it's hot, it will be level. And usually we have a magnet here because we don't want the contact to be not solid. So if we don't have a magnet, it's not going to have a snap action. And that's why we had mercury in all thermostats, because the mercury is liquid metal and it's very conductive. So once we bend the spiral panel, it will pour over and do the connection. However, mercury was not allowed it to be in the living space, so we stopped having mercury thermostat. Any questions so far? Are you bored? Are you tired? Should we stop? Guess the slide. Snap action. We don't want very close. Why? We don't want to be almost there. Inaccurate or else?
It's either just if you open or close. That's
Yeah,
it.
but why? We want it to be open and close only. Why? What if this like slowly creeps in and barely touching? What will happen?
It's running.
Huh?
It'll run.
Say it again?
It'll run.
It'll start to arc.
You would
Huh?
think the magnet
Arc.
would pull it down.
It will arc. It will have a spark, and we don't want that. Even 12-volt battery can give you a spark at the right distance. Again, air is not very perfect insulator. So if it gets very close, but not close enough, you have an arc, and you don't want that inside the living space. Magnet of mercury, and now we have digital thermometers. You want less, the less moving parts we have, the better. Why? Less failure. So again, I did the comparison between the DVD player and the VCR. VCR was very complicated mechanism, always breaks. The DVD player would never break, and if it breaks, you just throw it away. It's not worth changing that anymore. And now, if you have streaming, probably nothing breaks at all. Everything is completely solid and not moving. Okay, so I'll stop here. I think that's enough information. We'll go slowly. Next week, on Thursday, I finish this. But if not, we'll take it to next week.